So what I want to do is I want to remind you that division, the idea of dividing, is the same thing as factoring. And so what I want to do in this particular lesson is I want to show you how to use synthetic division to factor a polynomial. Now we've already reviewed factoring, and you're probably able to factor a polynomial like an x squared, a quadratic polynomial, as long as it's not too terribly complicated. Well, I'm going to show you how to use synthetic division to factor something a little more complicated. So let me remind you that factoring is the idea of breaking apart factors from a number, and factors are multipliers, right? So if we were to do 2 times 3 times 5, 2 times 3 is 6, and 6 times 5 is 30. So we can break 30 apart into, let's say, 15 and 2, because 30 divided by 2 is 15, 30 divided by 15 is 2, and 15 times 2 is 30. Now 2 cannot be factored anymore. Now technically speaking, you can factor 2 into 2 and 1, which is useful in what we're about to do. But generally speaking, we usually don't factor down numbers into themselves in 1. Okay, so we're going to leave the 2, but 15 can be factored down into 5 and 3. And so you can see we started with 2, 3, and 5, 3 prime numbers, and now this is the prime factorization of 30, 5, 3, and 2. Prime factorizations of numbers are very useful when doing even higher level mathematics. Okay, all right, so now what we're doing is we're going to, instead of factoring a number, we're going to factor a polynomial. So let's say that we had the polynomial x minus 5 times x plus 7 times x plus 8, okay? Now, if we were to multiply this out, it would be a third power polynomial because x times x times x is x to the third power. You would not like factoring that very much. But I can tell you that if we did multiply these out, it would make a polynomial that is factorable. And the way that it's factorable is down into 3 binomials. Binomials to the first power. Okay, generally to the first power. They won't always be to the first power, but usually we're going to be factoring down into the first power. Okay, binomials to x to the first power. Okay, all right. So the problem is that if this is a polynomial that's all multiplied out, how could you factor that? Well, remember, one of the rules of synthetic division is that you can divide by a binomial that is 1x to the first power. And so if this was multiplied out, in fact, let's go ahead and multiply it out right now. I have a calculator here that is actually capable of doing this pretty quickly. All right, so we'll do x plus 8, x plus 7, and x minus 5. And so if we were to multiply this out, it would become x to the third power plus 10x squared minus 19x minus 280. And if all you saw was this polynomial, you might be very intimidated. But what I'm going to do is I'm going to teach you how to not be intimidated by this polynomial and encourage you to understand that this can be factored down into 3 different binomials, linear binomials, okay? And that's what we're going to do right now, okay? All right, so let's start with something a little bit easier. Let's say that we have x squared minus 3x minus 10. Now, if I told you to factor this, you would not need to use synthetic division. You could probably say, oh, I know how to do this one. We already took a test on this. I know that negative 10, 2 numbers that multiply to negative 10 are negative 5 and positive 2. And negative 5 plus positive 2 equals negative 3. That's the middle number. So I know that this factors into x minus 5 times x plus 2. All right, excellent. Good review. All right, but here's what I want to do. because you already know that this factors into x minus 5 times x plus 2, I can now use that to show you how to do the same thing but using synthetic division. And if you can do the same thing using synthetic division, you can apply, and you might say, well, I would never use synthetic division on this. Good. But you could then use that procedure that you learned and apply it to something more complicated that you can't do using the other ways of factoring that we learned. Okay? So let me go ahead and show you what I would do. I call this trial and error. Trial and error. And you may say, well, what's trial and error? You know what trial and error is. Trial and error. Trial and error is a method of problem solving, not just math. This is just in life. Trial and error is a method of problem solving where you try something that might be the answer, you throw that thing in, see if it's the answer, and if it's not the answer, then you move on to the next thing. So you have a big list of possible answers, and you just go through the list until one of them, answers the question. That's called trial and error. So let's use trial and error with synthetic division to factor this polynomial. So here, the first thing we need is a list of numbers to try. The list of numbers to try are going to come from your last number. And the way you're going to find the list of those numbers is you need to identify all of the possible factors of the last number. Okay? So negative 10 can be factored into 1 and negative 10. It can also be factored into negative 1 and 10. It can also be factored into 2 and negative 5 or negative 2 and 5. This is pretty much it. In terms of whole number factors, these are all of the factors of this polynomial. And what we're going to do now is we are going to try as many of these. There's 8 numbers here. These are the numbers you would put in the half box. So let's try 1. I'm going to put 1 in the half box. Then I'm going to set up my synthetic division with this. I'm going to put a 1, then a negative 3, then a negative 10. Here's my synthetic division. So trial and error is I'm going to do the same thing. I'm going to put a 1 here, and if 1 doesn't work, I'm going to put negative 1 here, then I'm going to put 2 here, then negative 2, then negative 10, 10, negative 5, and 5, until something works. Now, how do I know that a number worked? Well, it works if you get a remainder of 0. Getting a remainder of 0 indicates that that number represents a factor of this polynomial, okay? Because it divides into it without having a remainder. And that means that it is a factor. When you factor something, there are no remainders. Okay, so now we're going to put our 0 here. 1 plus 0 is 1. 1 times 1 is 1. Plus negative 3 is negative 2. Negative 2 times 1 is negative 2. Plus negative 10 is negative 12. We have a remainder. It's not 0. Therefore, 1 is not one of the possibilities. All right, so we're going to change. Let's try negative 1 then. Negative 1. Put a 0. 1 plus 0 is 1. Times negative 1 is negative 1. Plus negative 3 is negative 4. Times negative 1 is 4. Plus negative 10 is negative 6. Remainder is not 0. Therefore, negative 1 is not one of our factors. Now let's try 2. So put 2 in the half box. Bring a 0. 1 plus 0 is 1. Times 2 is 2. Plus negative 3 is negative 1. Times 2 is negative 2. Plus negative 10 is negative 12. Again, not a remainder of 0. Therefore, 2 is not indicating one of our factors. Oh, I could have just put a negative in front. So now we'll try negative 2. Put a 0. 1 plus 0 is 1. Times negative 2 is negative 2. Plus negative 3 is negative 5. Times negative 2 is 10. Negative 10 and 10 is 0. We have a remainder of 0. Therefore, negative 2 represents one of the factors of this polynomial. Now, I want to remind you what this negative 2 means. It doesn't mean that our factor is x minus 2. It means that our factor is x plus 2. Remember that you have to be able to put this number in for x and then get 0. So, negative 2 plus 2 is 0. Therefore, one of our factors is x plus 2. Reminding you that when you do synthetic division, that when you're dividing by this polynomial, that you're reversing the sign of this. If it says plus 2, you're putting minus 2 here, right? Okay, well, what is the other factor? Well, that's represented right here, your answer. Well, you just learned synthetic division. What is the answer to this division? Well, it started out as x squared. That means that this is going to be x to the first, right? Minus 5. And therefore, it's x minus 5. And so, the factorization of x squared minus 3x minus 10 is x plus 2 times x minus 5, which you already knew. We did that previously. I'm simply confirming with you that this method of using synthetic division will give you the same answer. What I want to do now is try something that would be a little bit more difficult without synthetic division. All right, what about this one? Well, you would know how to do this one too, but it's not nearly as much fun as the other ones. Okay? You could use the product sum grouping on this. So you can multiply the 3 times the negative 10, you'd get negative 30. Then you can find the factors of negative 30. That would add up to negative 13, which are negative 10 and, in this case it would be negative 15 and 2, and you would break them apart. So you'd have plus 2x and negative 15x, right? Minus 10, 3x squared. Then you would group, right? And you could factor and then find your two factors. Now, you may say, well, I don't really like product sum grouping, and so I say, well, do you like synthetic division? Well, you may say, no, I don't like synthetic division, but I promise you, some of you probably do like synthetic division. After you do enough synthetic division, you realize it's so easy that you would rather do synthetic division than other mathematical techniques. And that's good because it's awesome. So here's what we're going to do. Look, we have the very same ending we had in the last problem. So we know that our factors are 1 and negative 10, negative 1 and 10, negative 2 and 5, and 2 and negative 5. So let's try these numbers and do synthetic division until we get a remainder of 0. Okay? Let's try 1. So put 1 in a half box. Put 3, negative 13, and negative 10. Put a 0, 3 and 0 is 3, times 1 is 3, minus 13 is negative 10, times negative 1 is negative 10. That gives us negative 20, not a remainder of 0. Okay? Well, then let's try negative 1. 0, 3 plus 0 is 3, times negative 1 is negative 3, minus 13 is negative 16, times negative 1 is 16, giving us 6, not a remainder of 0. Therefore, negative 1 is also out. So that's not a factor, that's not a factor. Let's try negative 2. 3, 0, 3 plus 0 is 3, times negative 2 is negative 6, minus 13 is negative 19, times negative 2 is 38, minus 10 is 28, not a remainder of 0, therefore negative 2 is not one of the factors. Let's try positive 2. Okay, put a 0, 3 plus 0 is 3, times 2 is 6, minus 13 is negative 7, negative 7 times 2 is negative 14, plus negative 10, that's negative 24, also not 0, therefore 2 is not one of our factors. Before I try 10, I'm going to try 5 and negative 5. Let's try 5. Put a 0, 3 plus 0 is 3, times 5 is 15, minus 13 is 2, 2 times 5 is 10, minus 10 is 0, and look at that, we've got our factor. This means that one of our factors is, since there's a positive 5 here, one of our factors is x minus 5, and our other factor is represented right here by the 3 and the 2. Started out as an x squared, so now it becomes x to the first. It's a positive 2, so plus 2. So our factor is 3x plus 2, and these are our two factors of this polynomial, using synthetic division to factor the polynomial. Okay? All right. And you may say, yeah, but that took so long, I would rather just do the product sum grouping. Good. That's awesome. But what happens if you now have a cubic polynomial? If you have a polynomial to the third power, well, it's harder to find techniques to factor, so synthetic division comes in really handy. Let's try one of those. All right, so let's say you have this one, x cubed plus 2x squared minus 43x plus 40. Okay, now we're in a bind. I have not taught you any techniques for factoring this, and I'm not sure whether you have learned any techniques for factoring this. And so, at this point, one of the best things that you can do is trial and error division. Now, you could do trial and error division using polynomial long division, but that can become really complicated. And so I would rather start with something simpler like synthetic division. Okay, so we're going to make my list of factors. I'm going to the last number here, the 40, and I'm going to make some factors. How about 1 and 40? Now don't forget about negative 1 and negative 40. Okay, so you got to be careful. Just because it's a positive number doesn't mean that it's automatically two positive numbers. Okay, because a negative times a negative is also a positive. What else? How about 2 and 20? 2 and 20. How about negative 2 and negative 20? Does 3 go into 40? Nope. How about 4? Yep. How about 4 and 10, or negative 4 and negative 10? 5 goes into 40. How about 5 and 8, or negative 5 and negative 8? Okay. I think that's it in terms of whole number factors. So here's what I'm going to do. Let's start with 1. Let's do 1, then negative 1. I'm going to start with the small numbers first, and I really don't want to do the larger numbers. So I'll go this way, then around and this way, and try and find the lowest number that'll help me factor. So I'll start with 1. I'm going to put a 1 in the half box. Then I've got a 1, a 2, a negative 43, and a 40. I'll draw my line, put a 0. 1 plus 1 is 1. Or excuse me, 1 plus 0 is 1. 1 times 1 is 1, plus 2 is 3, times 1 is 3, minus 43 is negative 40, times 1 is negative 40, and sure enough, on the first shot, I found one of my factors, because I have a remainder of 0. So now this positive 1 means that one of my factors is x minus 1. Okay, well, what do these numbers become? Well, it started out as x to the third power, so now this becomes x squared, 1x squared, or just x squared, plus 3x minus 40. And now, here's the cool thing. I don't want to just write down x squared plus 3x minus 40. What I want to write down, or what I want to do, is I still want to factor this. This is not fully factored. In order for this to be fully factored, I need 3 separate binomial factors, because it's a third power polynomial. So now I need to factor x squared plus 3x minus 40. Now I can do that in 2 ways. I can use synthetic division to factor this, or I can do what I already know. I know that negative 40 factors into negative 5 and positive 8, and that negative 5 plus 8 is positive 3. So I automatically know that my other 2 factors are x minus 5 and x plus 8. Okay? And so here's what I'm showing you. I'm really only using synthetic division to break down a third power polynomial into a second power polynomial, which I can then factor using other techniques that I already know. I'm now going to give you one that I want you to work on your own, and then I'll show you the answer. Plus 7 minus 26 minus 72. All right, why don't you try this one on your own, okay? Factor out the first binomial factor and then use any technique of factoring to get the last 2 factors. Okay, so hopefully you've already got an answer, and now you can watch me do what you did, and you can see if you did anything wrong, or you can see if I can confirm that you did it right. First thing I need is a list of possible answers. Okay, or possible factors, okay? So I'm going to take this number, negative 72, and I know that 1 and negative 72, or negative 1 and 72, I also know that 2 and negative 36 and negative 2 and positive 36. I also know that 3 and 24 and negative 3 and, 3 and negative 24 or negative 3 and positive 24. I also know that 4 and 18 or negative 18 and negative 4 and positive 18. Okay, 5 does not go in, 6 does go in. Okay, so I'll have 6 and negative 12 or negative 6 and 12. And I think lastly, what do I got? 9 and 8. Okay, so I'll have negative 8 and 9 or 8 and negative 9. Okay, so this is my list of all the possible factors. I know it's a lot. I'm going to start with the smaller ones to make it a little bit easier. So I'll start with 1. I've got a 1, then a 7, then a negative 26, then a negative 72. I'm going to put a 0 here. 1 plus 0 is 1, times 1 is 1, plus 7 is 8, times 1 is 8, minus 26 is negative 18, times negative 1 is negative 18, and we've got a negative 90. Remainder is not 0, therefore 1 does not represent one of the factors. So let's try negative 1. Negative 1. Okay, so put a 0. 1 plus 0 is 1, times negative 1 is negative 1, plus 7 is 6, times negative 1 is negative 6, minus 26 is negative 32, times negative 1 is 32, and we get negative 40, also not negative 1. Okay, so let's try the next one, which is 2. Put 2 here. Put a 0. 1 plus 0 is 1, times 2 is 2, plus 7 is 9, times 2 is 18, minus 26 is negative 8, times 2 is negative 16, and then we get negative 88. Not 0, therefore 2 does not represent one of the factors. So now we'll go to negative 2. Put a 0. 1 plus 0 is 1, times negative 2 is negative 2, plus 7 is 5, times negative 2 is negative 10. Minus 26 is negative 36. Negative 36 times negative 2 is positive 72. Minus 72 is 0, and therefore, look, we have found one of our factors. Negative 2 is represented in the factor x plus 2. And now these numbers down here represent what's left over of the factor, the other factor in this cubic polynomial. Started off as third power. This one's going to be second power. 1x to the second power, which means x squared. Positive 5 means plus 5x minus 36. This can be factored using product sum factoring. Negative 36 is created using positive 9 and negative 4. So positive 9 and negative 4, if you were to add them together, you'd get positive 5. Therefore, our other two factors are x minus 4 and x plus 9. Okay? And so we have now factored this into x plus 2, x minus 4, and x plus 9. See, our factoring is becoming more complicated, and synthetic division allows us the opportunity to do the more complicated factoring. All right, we're going to do maybe just a couple more examples. All right, last one. Why don't you try this? You may say, oh man, there's a 4 in front of that. It doesn't matter. You know how to do that with synthetic division. You can still use synthetic division to try and factor this. Go ahead and try it yourself. Pause the video, and then I'll do it. Okay, so let's identify our factors of negative 18. So we know we've got negative 1 and 18, or 1 and negative 18, sorry. I like to put the smaller number, positive first, then the negative. How about 2 and negative 9? And how about negative 2 and positive 9? And then how about 3 and negative 6? And negative 3 and 6? And I think that's it. Okay, those are all of our options. So there's our list. What do we got? 12 possibilities here. So let's start with 1. We'll put a 1 up here. Then we'll put our 4, our negative 27, our negative 79, and our negative 18. Now, what if this said, just perchance, what if instead this said 4x cubed minus 79x minus 18? What if we didn't have this term, this minus 27x squared? What if this is what we started with? What would you have to do in synthetic division? Remember that when we skip over a power, you would have to put a 0 in for the x squared. So you'd have to put a 0 here. I'm just reminding you in case you see a problem that looks like that, okay? But in this particular case, we don't have to put in any zeros. We've got third power, second power, first power, and then no x at all. So we're going to try 1. And we'll put our 0. 4 plus 0 is 4, times 1 is 4, minus 27 is negative 23, times 1 is negative 23, minus 79. This is like negative 100 and something, right? Negative 102, okay? This is not going to cancel out this negative 18. We need a positive 18 here to cancel this out. So we already know that 1 is not an option at this point. So we're going to cancel that out. Let's try negative 1, okay? Well, 4 plus 0 is 4, times negative 1 is negative 4, minus 27 is negative 31, times negative 1 is 31, minus 79, what is that, negative 48. So we know we're not going to get 18 again here, so we know that negative 1 is also not one of the factors. So let's move on to 2 and negative 2. Put a 2 here, draw our line, put a 0, 4 plus 0 is 4, times 2 is 8. Minus 27 is negative 19, times 2 is negative 38. Again, this can become negative 100 and something. This can become negative 200 and something. It is not going to cancel out the negative 18. Therefore, let's move on to the negative 2. Try another one. Put a 0 here. Draw our line. 4 plus 0 is 4. Times negative 2 is negative 8. Minus 27 is negative 35. Times negative 2 is 70. Minus 79 is negative 9, times negative 2 is 18, minus 18 is 0, remainder of 0, we did it. We know now that one of our factors is x plus 2. And so now these three numbers represent the other factor, which is 4x squared minus 35x minus 9. Now, we now want to factor this, and you have two choices. You can either use product sum grouping, which you may or may not like, to factor this, or you can continue factoring this with synthetic division using the factors of negative 9. Now we already know that 1 and negative 1 are out. Therefore, it's either going to have to be negative 9, 9, 3, or negative 3, because negative 2 is not a factor of 9, negative 6 and 6, 18 and negative 18 are not factors of 9. We can only continue with factors of 9. So let's go ahead and try that. Let's try to factor this polynomial using 3, negative 9, and 9, okay? So we'll leave this, well, we're going to set this x plus 2 on the side, maybe over here. This is one of our factors, x plus 2. And now watch this. I'm going to do a technique here where I am going to layer my synthetic division. I'm now going to use these three numbers as my top row. Okay, it's gone down by one number. I'm going to ignore the remainder over here, and I'm going to put a half box over here next to these three numbers and ignore everything else. And let's try out 3, shall we? I'll put a 3 here, draw a line, put a 0. 4 is 0 times 3 is 12. Minus 35 is negative 23, times 3 is negative 69, and it's not going to become 0. So we know that 3 is not one of them. So let's try negative 3, shall we? Negative 3, then we'll put a 0. 4 plus 0 is 4, times negative 3 is negative 12, minus 35 is negative 47. Negative 47 times negative 3 is like negative 100 and something. It is not going to cancel out this negative 9. Only a positive 9 will cancel out this negative 9 right here. So negative 3 is out. So let's try negative 9. Okay, let's put a negative 9 here. Put a 0. 4 plus 0 is 4, times negative 9 is negative 36. Minus 35 is like negative 71. This can be like negative 600 and something. Also not going to cancel out the negative 9. So we know that negative 9 is not the right number. Last one, and I know what you're thinking. You're thinking, oh, it's not even going to work out. You know, then Mr. Ryan doesn't know what he's talking about. Well, maybe you're right. Let's find out if I know what I'm talking about. 4 plus 0 is 4, times 9 is 36, minus 35 is 1. 1 times 9 is 9. We get a remainder of 0. And we know now that we got to reverse the sign of this to minus 9, so we have x minus 9. So we know that x minus 9 is a second factor. And what's the third factor? Well, these two numbers represent the third factor. We went from x to the third to x to the second. Now we're going to x to the first. This is an x to the first. This is a positive 1. And therefore, it's 4x plus 1. That is the third factor. We're going to put it over here. 4x plus 1. And this is our factored out version of this. Now, you may be thinking to yourself, wait a minute. Didn't we try -1 and it didn't work? Yes, we did. But we tried it with synthetic division where there wouldn't have been a 4 in front of the x. So x plus 1 is not a factor, but 4x plus 1 is a factor. And so now you can see by dividing out x plus 2 and x minus 9 through synthetic division reveals the factor 4x plus 1, and this is how we use synthetic division to factor larger polynomials. Okay? All right, so practice with that. That technique is going to come back, I think, next week or the week after, so be ready for that. But for now, just focus on the synthetic division and the factoring using synthetic division.